so I know the vertex is 3, 3. And the point is 4, 5. How is that going to work? I think I'm going to drop everything at least. Well, we probably should start with the form that allows you to look at the vertex, where H and K is the vertex. Taking a note that this minus sign on the H changes but does not on the K. And if this is my vertex here, so it says the problem, then I have y is equal to a x minus 3 squared plus 3. Notice there's a minus sign here because this changes but this does not. So it looks something like this. Not something like this. It looks exactly like that. The only value I don't have in this particular case is what? I don't know what A is. But I know that this point has to work, and this is my x and this is my y, so 5 in for y must equal A times 4 in for x. 5 is equal to A times 1 squared plus 3, or 5 is equal to A plus 3. Subtract 3, subtract 3, 2 is equal to A. So we can take that and we can install it right back into there. So y is equal to 2 times x minus 3 squared plus 3. And then you start looking for this answer and you say, uh-oh, these are all in the other form, ax squared plus bx plus c. So how do I turn this back into the other form? Foil this out. 2 times x squared minus 6x plus 9 plus 3. 2x squared minus 12x plus 18 plus 3. And then you can see the rest here. And that is the vertex, and the point is 3 minus 5. So y is equal to a times x plus 4 squared minus 7. Why is that a plus 4? Yeah, it's the opposite sign. Now, we have this point here, 3 minus 5, so minus 5 is equal to a times 3 plus 4 squared minus 7. So a is equal to 2 over 49. Which rules out this one, rules out that one. And since a has to be plus 4 are both there, so the choices are between this one, and this one. What do you think? The minus one. Ax squared plus bx plus c4. No big deal. We're going to complete the square to do this. The problem is that both of these have a 1 in front of the square term. That's the easy type, right? I should have given you ones like this on page 329, 31, 32, 33, and 34. Okay? Those 4 and others on there like them would be best shown to you on a review. So to help yourself, go look at those as well as these two right here. I'll do these two and perhaps number 34 or something, so you can see how it's done with something other than a 1 in front. It's not much different, but there's a significant difference there. This one is ideal actually because what you want to do is basically complete the square. This time, though, we don't really have an equal sign, even though it looks like we do. We're not going to mess with equaling, adding things on both sides. What would you like to see sitting right here? 81. Why? Because half of 18 is 9. 9 squared is 81. I can't just go adding 81 because I feel like it, even though it would be nice if I could do that in math. If I add 81, I have a whole new function here, don't I? So to compensate, I'll just go ahead and subtract it. And then I'll use the property that associative property of addition that says I can associate any group of addition ones I want to make this become x plus 9 squared minus 81. And then circle the correct answer. That's not too hard. This one's very similar. Here what I'm going to do is take the x squared plus 14x and I'll put my plus 53 over here. And I'll come back in and say, what's half of 14?
7.
7 squared is 49. So I'm going to subtract 49. And once again, the associative property will group those together. And this becomes x plus 7 squared. And 53 minus 49? 4. So those aren't too bad, right? You know what you're doing? Let's take a look on page 329 and number 34. Somebody would read that to me, it'd be nice.
Y equals negative 5x squared minus 20x plus 13.
Okay, in this case, what is in front of the x squared term? Not this nice one that you see here and here. Now you actually have stuff to do. So how are we going to turn that coefficient into a 1? Well, normally we would divide. But since we don't have an equals term to work with, yeah, we're going to factor just the first two terms. Minus 5 x squared. You do it this way. You tell me, minus 5 times what equals minus 20x? Positive 4x. Yeah, make sure you understand the sign change there. Because minus times positive is negative. And I also left room. Actually going to do 4. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 in here and then turn around and subtract it there. So far, not too different, but here's the key step right here. This is the one that kind of confuses people the most. I need to bounce this minus 4 out like this. I'm going to take the minus 5 out and bounce him out that way. This is something new. You probably haven't seen this before. I'm going to actually distribute this to only one part of the parentheses, not all 4 pieces. So my next statement will be minus 5 x squared plus 4x plus 4 minus or plus 20 plus 13, because minus 5 times minus 4 bounced out as a positive 20. I don't know of a better way to put that. I just have to bounce it out. This is good though, because this is a perfectly square trinomial right here, x plus 2 squared. And this is what, 33? Instead to put it in the form like this, it is. So write down these other 3, I guess, now, and practice those as well as these 2, because I really should have put